Welcome back, folks. So I hope you tried this out and figured out the math. But if you didn't, let me take you through it. X, which we don't know, which we're going to find out. But we also have this LED. Now when you look at this LED, I'm going to introduce you to a very, very important concept over here, which is trying to figure out whenever you're using a new component, what are the ratings of that component? What are the power ratings for this component? The power ratings of any component can be found in the data sheet for that specific component. And you'll get this from your manufacturer, you'll get this from the vendor that you're buying from, or from the website that you're ordering from. In this case, the LED that we're using has a Vmax of 3 volts and an Imax, which is the max current of 10 milliamps, which is equal to 0.01 amperes. So once we know this, what is the Imax and the Vmax, we can try and figure out this X, or how much resistance is what we need. So let's try and do that math. So 9 volts is our existing voltage. If we subtract 3 volts from that, we get 6 volts. Okay, so we need to technically get rid of 6 volts in this circuit, right? So once again, going back to our beautiful Ohm's law, which is V equals to IR, I'm going to put 6 volts over there, equals to I, which is the Imax, which is 0.01 amperes, multiplied by X. Now you know what I'm getting at. What is X? Simply 6 volts divided by 0.01 amperes, which gives us a value for resistance at 600 ohms. So this is equal to 600 ohms. So technically, this resistor that I need over here has to be a minimum of 600 ohms. What happens if you increase that resistance? The LED will dim and you will get a less bright LED. If you increase this or if you reduce this down, once again the LED will blow up. So you need a minimum of 600 ohms. But you don't really get a 600 ohm resistor out there. In your kit, you have 3 220 ohm resistors. You can line them up and you'll get 660 ohms. Or you can go ahead and connect a 1 kilo ohm resistor, and that's what I've done over here. This is a 1 kilo ohm resistor connected to the LED. And now I'm going to do the same thing. I'm going to light this up. That's the positive and that's the negative, right? So we can see that from the LED. This is the positive light and the negative. I'm putting it right here across the circuit, and I'm going to connect the positive of the battery to the positive and the negative to the negative side of the circuit, and voila, we have completed the circuit and the LED lights up without blowing up, and that's key. This is the concept behind a potential drop, and you need to do potential drops to be able to safeguard your components, because not all components will always work at 9 volt or 3 volt or 20 volts or whatever you're playing with. You'll always have certain components in your circuit that have a rating for example, 3 volts in this case, which is an LED, and certain components that might require a higher voltage. And we'll get to that in a few other sessions where you'll need higher voltages to turn on your circuit. This is a very important principle, and you guys will be using this all the way in your different projects. So I hope you get that concept. I'll see you guys in the next video.